In section 5, we've got yet another way to solve a quadratic equation. This time we are going to use the infamous quadratic formula. And that infamous quadratic formula can be found right here in your notes. And it goes like this. The solutions, there are two of them here, x equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Now these are going to return your real solutions to the quadratic equation. Ax squared plus bx plus c is equal to 0. Now note that that part underneath that radical, b squared minus 4ac, has to be greater than or equal to 0. It has to be positive or 0 in order for there to be real solutions. More about that a little bit later on. All right, so let's get an example here. Use the quadratic formula to solve x squared minus 6x plus 5 is equal to 0. So notice that your quadratic is already set equal to 0. Let's list out our a value, our b value, and our c value. All right, next we're going to follow that formula that says x is equal to the opposite of b. So that's the opposite of negative 6, so it's positive 6, plus or minus the square root of our b squared. Now I'm going to put that b squared in parentheses here, negative 6 squared, minus 4 times my a value times my c value. Okay, now that's all being divided by 2 times our a value. All right, so let's start simplifying from the inside out. To this negative 6 squared is 36 minus 4 times 1 times 5. That's 36 minus 20. So I have 6 plus or minus the square root of 36 minus 20, all divided by 2. All right, let's simplify further. We've got 6 plus or minus the square root of 16. That's the result of 36 minus 20, all over 2. And that leads us to 6 plus or minus 4, all over 2. All right, now we are going to simplify this expression to come up with our two values, or our two solutions. X can equal 6 plus 4 divided by 2, and x equals 6 minus 4 all divided by 2. That's what that plus or minus 4 means. Those are our two solutions. So that's 10 over 2 and 6 minus 4, which is 2 over 2. So my two solutions are 5 and 1. If we were to graph this quadratic equation, we would see that it crosses the x-axis when x is equal to 5 and when x is equal to 1. All right, let's try another quadratic formula problem. We got 12x squared minus 4x minus 5, so our a value is 12. Our b value is negative 4. Our c value is negative 5. All right, so we're going to follow it. The opposite of b, so that's the opposite of negative 4, which is positive 4, plus or minus the square root of b squared, so that's negative 4. And I'm always going to put that b in parentheses when I square it, minus 4 times a times c, which is negative 5. All right, now that's all being divided by 2 times my a value, which is 12. All right, so again, we're going to simplify that inside part first. Okay, doing the math on that, we got 4 plus or minus the square root of 256. That's the result of taking 16 and adding 240 to that, all divided by 24. All right, now the square root of 256 is 16, so my two solutions here are 4 plus or minus 16 all over 24. Okay, now we're going to simplify that. We got 4 plus 16 all over 24 and 4 minus 16 all over 24. So my two solutions here are going to be 20 over 24 and negative 12 over 24. So we can reduce those even further. That's going to reduce to 5, 6, and negative 1/2. All right, so our third example here, now we have using the quadratic formula 1/2 x squared plus x minus 10. We are going to solve this one using the quadratic formula again. We have our a value of 1/2, our b value of 1, and our c value here of -10. All right, so plugging this into our quadratic formula, we're going to take the opposite of b, so that's -1 plus or minus the square root of 1 squared minus 4 times 1/2 times -10, all being divided by 2 times 1/2. Okay, well, 2 times 1/2 is really nice. That's just 1. So really, I'm just working with my numerator here. So I have -1 plus or minus the square root. Well, that's 1 squared. 1 squared is 1 minus 4 times 1/2. That's 2. 2 times that -10 is 20. So that's going to be 1 plus 20. So that's the square root of 21 in the numerator. So -1 plus or minus the square root of 21. Now we don't need that big, huge square root sign, so we'll just do it like that. All right, so 21 is not a perfect square, so we can just leave our solutions just as you see them here. We have x is equal to -1 plus the square root of 21 and -1 minus the square root of 21. Likewise, we could put those into our calculator and get their decimal equivalent. All right, skipping over example 4, we're going to move on to the back page and talk about the discriminant. So the expression b squared minus 4ac, this is the part that appears underneath that radical symbol in the quadratic formula, is known as the discriminant. And when the value of the discriminant is found, it can be used to determine the number of real solutions. So when that discriminant, b squared minus 4ac, is greater than 0, in other words, it's a positive number, then there are going to be 2 real solutions. It's going to cross that x-axis in 2 distinct points. However, if the discriminant, b squared minus 4ac, is equal to 0, then that parabola is just going to bounce off that x-axis and there will only be 1 real solution. And there'll be 1 x-intercept. If b squared minus 4ac, the discriminant, is less than 0, in other words, it's a negative number, then there will be no real solutions and no x-intercepts. So here in example 5, they just want us to evaluate the discriminant and determine the number of real solutions and x-intercepts. All right, so taking a look at part A here, our quadratic equation is in standard form, so it equals 0. My a value is 2, my b value is -3, and my c value is -1. Now remember, the discriminant is just the b squared minus 4ac. So I'm going to take my -3 squared minus 4 times 2 times my -1. That gives me 9 minus, this is 4 times 2, which is 8 times a -1. That's -8. So that's 9 minus a -8 turns into plus positive, so that's 17. And this is a positive number. Positive numbers means that there are 2 real solutions. Now from here, we could go ahead and use the quadratic formula to find out what those 2 real solutions will be. All right, moving on to the next one here in letter B. We see that we again once again have our quadratic formula set up in standard form, and if we set it equal to 0, we can let our a value be -1, our b value is +1, and our c value is -6. Evaluating the discriminant, b squared minus 4ac, will give us 1 squared minus 4 times a -1 times a -6. All right, that leads us to 1 squared, which is 1, minus 4 times a -1 is a -4, times a -6 is a +24, so that's -24. All right, that's going to come out to be -23, which is a negative number. And if you have a negative number, remember you have 0 real solutions. Your parabola, in other words, will not cross the x-axis. All right, in our next example here, we got letter C, and again, this is going to be set equal to 0. Our A value is 1, our B value is 12, our C value is 36. So B squared minus 4AC is going to give us 12 squared minus 4 times 1 times 36. Well, this is going to come out to be 144 minus 144, which equals 0. And when it's equal to 0, that means there is one real solution. All right, finally, we have some properties, and we want to sketch the graph of a quadratic with these characteristics. My A value, remember this goes like this, ax squared plus bx plus c. My A value is less than 0. So that means my parabola must open down. And it says b squared minus 4ac is equal to 0. And that must mean it just has one real solution. All right, so a possible graph for this could be, if this were your x-axis and this were your y-axis. We'll just get those nice and straight. We have a parabola that opens down and touches the x-axis in one point. So this could be a possible graph of that quadratic equation with those given characteristics.